Question 18. Now this is the same one as we did in class. I don't have too many examples of these, so I've had to use the same one again. Now remember, where you've got to construct and then solve a quadratic equation, the hardest bit is part A. Okay, and really your starting point is just to try and leave the algebra aside and just think what normal maths is underpinning the question. Now at the end of the day, the area of the trapezium is 36. This is an area of a trapezium question. So how do you work out the area of a trapezium? Well, you start off by averaging the parallel sides. That's these two. How do you do an average? Well, you add together and then you divide by 2. So x plus 2 plus x plus 6, and then you divide this by 2. So gather up the top bit, that is 2x plus 8, then you halve both bits, giving us x plus 4. So the average of the parallel sides is x plus 4. So what do you then do with the to work out the area of a trapezium? Having averaged the parallel sides, you take this and you multiply it by the heights. So we've got x plus 4 to be multiplied by x minus 5. So that is what gives us the area of the trapezium, x plus 4 times x minus 5. But we are told this equals 36. So we can make that equal to 36. So we then multiply out the pair of brackets, giving us this, take away 36 from both sides, and that gives us what we were asked to show. Now that's the hard bit, that's the 4 marks. Now from then onwards, A, it's more familiar, but B, all of this could be done without understanding part A. We're now just being asked to solve something, so even if you'd messed up part A, you should be able to do part B, because this is much more familiar. So we can solve this by factorising first. So two magic numbers that multiply to make minus 56, but add to be minus 1, that's 7 and minus 8. So x plus 7, x minus 8 equals 0. So our two solutions are x equals minus 7 or x equals 8. Now for part 2, find hence, so using this information, find the length of the shortest side of the trapezium. So up here, these are the lengths of the trapeziums. So x, whatever x is, add 2, whatever x is, take away 5, whatever x is, plus 6. Now in theory, we've got two solutions we could use, but clearly you can't have negative lengths. You know, minus 7 add 2 is minus 5. That's just not viable. You know, that sort of Doctor Who stuff. So you can discard that solution for part 2 and just use the realistic solution of x being 8. So when x is 8, this length is x plus 2, that length is 10, that length is x take away 5, which is 3, and this length is x plus 6, which is 14. Question asks for the shortest length, so that's 3.